Okay, so go ahead, look at the camera, introduce yourself, and tell us where we're at in the class you taught.
My name is Natalie Johnson, and I teach pre-calculus at Mattia Valley High School in Aurora, Illinois.
And what grade was that?
Grade grades 10 through 12.
10 through 12 were
Yes.
in that classroom. Okay,
Yes.
cool. That's what
Sorry.
we need.
Great.
So we're rolling now. So first question, we want to understand the decisions you made in planning for this lesson and how it fits into the unit and year. How does this lesson connect to and build on students' prior skills and knowledge? What was taught before this lesson and what will come after it?
Well, what we talked about prior to this lesson was functions. Everything that we're dealing with today is functions, domains, ranges, graphing them, looking at higher order polynomials, and then taking that into the discussion of exponentials and logs. The students understand that there is a connection between all functions and how they behave, how they look graphically, and they're able to take that and make that connection and extrapolate that into exponential equations and logs.
Discuss the sequence of the lessons that surrounds this one lesson.
The sequence of lessons that surrounds this whole lesson is that one of the things that the students can take from prior skills is graphing a line. Once they graph a line, the line can move vertically or horizontally. And then they can take that and mimic it in exponential functions. And then they can take that and mimic it as they change exponents to logs, change the different forms of the equation, use that same methodology that they use with lines to be able to graph logs and graph exponent functions, which are really the same, and that is the huge discovery in the whole thing.
Talk about the standards or cluster targeted in this lesson. What did you do to make the lesson reflect the full intent of that standard or cluster?
The functions are the main target of this lesson. Once students understand what functions are, they understand domains and ranges that are connected with functions, then they can use it really with any function. As long as the function adheres to continuity, then the students can take anything that they've learned before, all the way from Algebra 1, all the way through pre-calculus.
Which of the core action indicators do you think this lesson best exemplified, and how did you plan for this?
I need to go to my notes.
Okay. Not a problem.
Okay. Which core action? Okay.
And which of the core action indicators do you think this lesson best exemplified, and how did you plan for this?
The core action that this lesson exemplifies is evidence of student learning. The evidence that the students were able to demonstrate was being able to graph functions with fluency, being able to use what they have learned in the past to be able to use it with exponents and logs. Once they are able to solidly graph the equations that are presented to them and demonstrate the asymptotes, then I feel comfortable and confident that they have learned that skill very well.
We're interested in how the shifts required by the CCSS are being incorporated into your classroom. Discuss how this lesson illustrates the shifts required by the CCSS.
The shifts that are required by Common Core are ones of coherence, fluency, and rigor. The rigor is by nature identified by the mere curriculum of the course that we were teaching. The students are able to demonstrate that, particularly by using skills that they have learned prior to be able to apply them to the current lesson. The the rigor or the focus of the lesson today had to do with functions again. Once students understand the definition of functions, once they are able to use it in prior skills, then they're able to extrapolate it to the current lesson of functions and exponents.
How did you teach the content of this? How did you teach the content of this lesson prior to the CCSS? What's the same and what's different?
Sure. Prior to Common Core, what I would normally do is I would demonstrate how to graph logs and how to graph exponents and how the two are connected. The difference now is that I have the students to discover that they can do those things without me. And what I do is I prompt them with a set of warm-up questions that force them to have to think more high level and to be able to answer the questions that I would have asked them without me prompting them. So through the warm-ups and through their own discovery and by them asking questions of each other and being able to discover the answers on their own is the biggest difference that Common Core has made.
Good. Student engagement is crucial to the work of the CCSS. We want to understand how you ensured that all students had the opportunity to productively engage in the work of the lesson. First question. How did the students handle this lesson? Did they understand the mathematics of this lesson? And how do you know?
All students were able to participate because of the way that I had the room really designed. The room was set up so that the students could work in small groups and they had to discuss the warm-up that I presented to them. Once I gave them a few minutes to discuss the warm-up questions, then I was able to call on any student. I was able to walk around and listen to the conversations that they were having. I was able to observe the participation of all the students in the room and to ask them questions based off of the questions that were asked of them in the warm-up. And by my observing them, I was able to understand or assess how much they had actually learned based on the questions that they were asking or the discussions that they were having with each other.
Explain how you differentiated in this lesson. Did all students have opportunities to work on grade level content? If all students did not have this opportunity, please explain why.
All students did have the opportunity to work on grade level with this particular lesson. It sort of is begged for in the course itself or in the content. The prior skills that they needed in order to be able to demonstrate that they understood the current lesson was one of the things that they had to be able to demonstrate with fluency. By being able to use the prior skills, they were able to then apply them to this current lesson. And again, by assessing them, by listening to their conversations, it allowed me to be able to determine who was grasping and who was not. If a student was not grasping, I was able to prompt them to ask questions of things that I knew that they were solid on so that they can eventually figure it out. So if a student was having trouble, I was able to work with them by asking them specific questions based on skills that I knew that they were solid in until they worked their way up to figuring out the current problem.
Let me make sure. Okay. Which behaviors from Core Action 3 did the students best exemplify in this lesson? And what actions have you taken as a teacher to make that happen?
Okay, I need to pause.
Okay. You want me to read it again, or you think?
I think I have it.
Okay.
From Core Action 3, the collaboration piece is pretty important for students to be able to hear discussions that other students are having. I think that it is important that students can hear some of the pitfalls that other students are having so that they basically know that they're not alone and that it's okay to not know. It's also okay for them to continue to work through to try and figure out the means to an end, if you will, as opposed to just quitting. So I think that the collaboration piece was really important, and then being able to facilitate them persevering, I think was really important.
Would you like to comment on any of the submitted student work? Was there something that delighted or surprised you with this work?
There were some surprises. Some of the kids had flipped the equations or flipped where the asymptotes were. Some of the asymptotes should have been vertical as opposed to horizontal, but then I made them go back and do a T-chart so that they can figure out, where is the equation really building towards, so that they had a better understanding. And once they became solid in that, then they were able to see patterns, and I think that that's pretty important.
Great instructors are continuously learning. We want to understand what you celebrated in this lesson and what you would improve upon. Reflecting on the lesson, what worked particularly well and what might you do differently?
One of the things that that I was very pleased with was the fact that some of the students who normally would not have spoken up, they felt very comfortable in asking questions of their peers, and I think that was great. I think that with Common Core, it allowed me to be able to build a warm-up in a way such that students were able to feel that it was okay to ask questions. Some of the ways that I did that was by saying justify your answer. And so they could no longer do a yes, no, true or false type of response. They had to actually demonstrate the knowledge. And I think that that was the biggest lesson that I learned through this whole thing. Lastly, I would say that with Common Core, I really think that it is a way for students to really demonstrate solid knowledge with regards to the standards, with regards to just solid mathematical knowledge. They use the correct verbiage. They use the correct mathematical terms as opposed to, for example, top and bottom. They would now say numerator and denominator. And I think that that helps them to really learn as they continue to excel mathematically.
Last question, were there any surprises or unexpected student behaviors or reactions?
There were no surprises. I think that the class works really well together. For the students who normally would not speak up, the other students wanted them to participate, and everybody really wanted everybody to be successful, which I think is really part of the core.
That's it. Good job.
Thank you.
You get your coffee?
Yeah.